Next we will do hydrolysis of salt. Now what is hydrolysis? First of all, remember that hydrolysis is the reverse of neutralization. Now what is that? In neutralization, acid reacts with the base to form salt and water. What I said, it's the reverse. So salt will react with water to produce either acidic or basic solution. That is called as hydrolysis. I'll tell you the definition, but understand it first. Salt will react with water, because I said it's the reverse of neutralization. Salt will react with water to form either acidic or basic solution. That is called as hydrolysis. That is known as hydrolysis. So you will say, sir, if it forms a neutral solution? No. Neutral solution means it is not undergoing hydrolysis. If acid and base, salt and water reacts to form acid and base, and the resultant solution is neutral, then it is not hydrolysis. Listen very carefully. It is not hydrolysis. It does not come under hydrolysis. Now, first let me tell you the definition, then I will tell you the category. What is then the definition of hydrolysis? Listen carefully, you may write it down. It is the interaction of oppositely charged ions of acid with oppositely charged ions of water, resulting in the formation of either acidic or basic solution. It is interaction of oppositely charged ions of salt. Sorry, it's not acid, it is salt. It is interaction of oppositely charged ions of salt with oppositely charged ions of water, resulting in the formation of either acidic or basic solution. It is known as hydrolysis. What I said you? Acidic or basic. I did not say neutral. I did not say neutral at all. Okay. So what I said, that is, it is the interaction of oppositely charged ions of a salt. So here let us take sodium carbonate with water. Alright. So let me write water in this way, HOH. It will be easy for you to understand. So now here it is plus, it is minus, it is plus, it is minus. So what will happen? Sodium will go with OH, that is NaOH, and this will react with, that is 2 sodium, so it is to balance it, I will put it as 2. Alright. So, and this will react with carbonate to forms H2CO3. But I said you already, H2CO3 is a weak acid. Carbonic acid is a weak acid. It will decompose to give you water and carbon dioxide. Alright, it's a weak acid, remember that. H2CO3, it's a weak acid. So it is a, what is that? Strong base. And what I said, it is a weak acid. That means, if it is strong base, that means OH minus ion concentration is greater than H plus ion concentration here. Now this square bracket means, I told you earlier also, it means what? Concentration. This, how will I read? Concentration of OH minus. This is concentration of H plus. Alright, don't need to write in word, concentration of. This square bracket means it is concentration. So when the concentration of OH minus is greater than H plus ion, what is that? The resultant solution is basic. Definitely, if this is more than this, the resultant will be basic in nature. Alright, fine. Now, in this way, like suppose instead of this sodium carbonate, if I take potassium sulfate, let us say, plus water, what will I get? I will get, that is nothing but potassium hydroxide, and what will I get? Sulfuric acid. See very carefully, potassium hydroxide, sulfuric acid. Now, potassium hydroxide is a strong base and it is a strong acid. So here OH minus concentration is equal to H plus ion concentration, because strong base means I have said it will dissociate almost completely into its ions. Strong acid means it will dissociate almost completely into its ions. So both the concentration is same. The resultant solution will be what? It will be neutral. Alright. So hence for that particular purpose it does not undergo hydrolysis. This particular one is not an example of hydrolysis. So remember that a salt of, this is salt of what? Strong base and strong acid. Remember that. Note it also. A salt of strong acid and strong base never undergoes hydrolysis, because the resultant solution is neutral in nature. Resultant solution is. Alright. A salt of strong base and strong acid. This is salt of strong base and strong acid. Never undergoes hydrolysis, because resultant solution is neutral. But in hydrolysis, the resultant solution has to be either acidic or basic. Got it? In nature. So I think you got it. So hence, hydrolysis is of 3 types. 3 types. What is that? A salt of strong base weak acid, as you can see it here. A salt of strong base and strong acid, I said, never undergoes hydrolysis. We can also have that is salt of, that is weak base plus strong acid. This is second one. This is your first one, strong base weak acid. This is weak base strong acid. And third one is weak base and weak acid. Again I repeat, strong base strong acid does not undergo hydrolysis. Now weak base means what we can say? We can say calcium hydroxide, zinc hydroxide. Strong acid means HCl, we can say that. So to explain this, let me take an example. Okay, I think you understood this one. Let me wrap it this one. Let me take an example here. That is weak base, what I said, let us take here copper hydroxide or calcium, anything you can take. And strong acid, that is HCl. So this is nothing but neutralization I am writing. Alright, it is the reaction I am writing neutralization, but I am not teaching neutralization. Neutralization is over. That is what I said, hydrolysis. So in hydrolysis, what I have to do then? Should I write this equation in this way? No. Then what I have to write? When copper hydroxide reacts with HCl, what is going to form? Copper chloride and water. So what will I write? Copper chloride and water will give you what? Same thing. Reverse. Copper hydroxide and that is nothing but HCl. Clear? Copper hydroxide and HCl. So copper hydroxide is a weak base. Weak base, and this is your strong acid. So here OH minus ion concentration is less than H plus ion concentration. So as a result, the resultant solution is acidic in nature. It is acidic in nature, you can say that. Over. Now weak base, weak acid. Weak base means like you can take that is copper hydroxide, and weak acid means you can take like carbonic acid. We can take, like, the salt will be what? Copper carbonate. So when copper carbonate reacts with water, what do you get? You get copper hydroxide and carbonic acid. This is also weak base, this is also weak acid. So here either OH minus ion will be more than H plus ion concentration, or H plus ion will be more than OH minus ion concentration. So resultant solution may be either acidic or basic, but it will never be neutral. It will never be, because it will never be equal. Either this concentration can be more than this, or this concentration can be more than this. It depends. So resultant solution can be either acidic or basic, but here it is very crystal clear. So hence we are having three categories, that is strong acid, weak base, weak acid, strong base, weak acid, weak base. Strong acid and strong base never undergoes hydrolysis. I think it's clear. Thank you.